This attack just reached my firewall, but it never reached my system. Why? Watch this. I'm sending a known exploit pattern from my Ubuntu desktop to a test server. The request goes out, but look at the firewall. The packet is blocked. It never makes it through. My endpoint has no idea an attack even happened. No alert. No infection. No compromise. Just silence. Because the threat died at the gate. This is the difference between detection and prevention. And today, we're building the system that makes this possible. Welcome back to TechSky. In our previous lab, we built the Watchtower. Your Ubuntu server now has 3 monitoring layers. T-Shark captures raw packets. Zeek generates protocol intelligence. Suricata runs in detection mode, alerting you when it sees threats. But here is the problem with detection alone. When Suricata detects an attack, it creates an alert. It logs the event. But the attack still happens. The malicious traffic still reaches your system. The exploit still executes. You know you were attacked, but only after the damage is done. That changes today. We are deploying pfSense, an enterprise firewall platform that sits between your network and the internet. We are installing Suricata in intrusion prevention mode with inline blocking. When it detects an attack signature, it will not just alert you. It will drop the packet immediately. The attack stops at the firewall. Your endpoints never see it. We are also adding geo-blocking to block entire countries, creating rules for known malicious IP ranges, and building a true security perimeter. By the end of this lab, your network will not just see threats, it will stop them. Let's build your defensive fortress. Let's get pfSense installed. Open your web browser and search for pfSense. The first result takes you to the official pfSense website. Navigate to the Download tab at the top of the page. You will see the Netgate installer download page. Netgate is the company that develops and maintains pfSense. Look for the download button and click it to access the installer page. The installation is completely free. From the installation image dropdown, select the virtual machines option. This gives you the ISO image that is optimized specifically for virtualization environments like VirtualBox. Add it to your cart and proceed through the checkout process. The checkout requires creating a free account. Enter your name, email address, and create a password. The Netgate shop page opens. Click the cart button again. Scroll down and click checkout. Even though you see a payment page, do not worry. You do not need to enter any card information. Just fill in the required billing address information, check the terms and conditions, and complete the order. Once your order is processed, the download button becomes available. The download is a zip file containing the pfSense ISO image. After it finishes downloading, extract the zip file to reveal the ISO inside. Open VirtualBox and create a new virtual machine. Name it pfSense Firewall and select the ISO image you just extracted. For the operating system, choose BSD as the type with FreeBSD 64-bit as the version. In the virtual hardware section, allocate 2 GB of RAM to give pfSense enough resources to run Suricata IPS efficiently and handle firewall operations without bottlenecks. Set the CPU count to 2 cores. For storage, allocate 20 GB of disk space, where pfSense will store logs, rules, and configuration data. Now we configure the network adapters, and this part is critical for the firewall to function properly. Open the network settings for your new virtual machine. Adapter 1 should already be set to NAT by default. This becomes our WAN interface that connects to the internet. Leave it as NAT. Switch to Adapter 2 and enable it. Change the attachment type to host-only adapter. This becomes our LAN interface connecting to your internal lab network. Click the Start button to boot pfSense for the first time. The pfSense installer boots up and displays the copyright and license information on screen. Press Enter to accept the license agreement and continue. The next screen asks what you want to do. Press Enter to install pfSense on the system. It moves to Network Setup. Press Enter again to proceed with setting up the network configuration. Now it needs to know which interface should be your WAN connection. You will see EM0 listed as an option. Press Enter to select EM0 as the WAN interface. The system processes this selection and asks you to continue. Press Enter to move forward as it configures the WAN settings. Next comes the LAN interface selection. The screen shows EM1 as the option. Press Enter to select EM1 as your LAN interface. Now you need to configure the LAN IP address. By default, it wants to use a different subnet than our lab. You need to change it according to your lab subnet. I am setting mine to end with .254 to serve as the gateway address for my network. Enter your IP address that matches your lab configuration. After setting the IP, it asks about DHCP configuration. Adjust the DHCP range start and end addresses accordingly for your subnet. Then press Enter to continue. The screen displays both your WAN and LAN configurations for review. Confirm that both look correct, then press Enter to continue. The system now checks internet connectivity through the WAN interface to verify everything is working properly. Wait while this connectivity check completes. Once connectivity is verified, press Enter to install pfSense Community Edition. The file system configuration screen appears, asking how you want to set up the disk. Press Enter to continue with the default settings as they are. The next screen asks about ZFS virtual device type configuration. Press Enter again to accept the default configuration. Now it shows disk selection options. Press Enter to proceed with the disk selection as it is. A confirmation screen appears, warning that the disk will be formatted. Press Enter to confirm and begin the partitioning process. The disk is partitioned and prepared for installation. It asks which version to install. Press Enter to install the current stable version. Installation starts, and you can see progress as files are copied to the virtual disk. This takes a few minutes to complete. After everything finishes, a completion message appears. Press Enter to acknowledge that installation succeeded. The system prompts you to reboot. Press Enter again to reboot pfSense. It reboots, and you will notice that after reboot, the setup loops back to the beginning. This is normal behavior, because the ISO is still attached. Close the pfSense Firewall virtual machine window to shut it down. Click Settings on the pfSense Firewall virtual machine. Go to the Storage section. You will see the Netgate ISO still attached under the IDE controller. Right-click on the Netgate ISO and select Remove Attachment. Click the Remove button to detach the ISO from the virtual machine. Press OK to save the changes. Now start pfSense Firewall again. This time it boots from the installed system instead of the ISO. The boot process completes, and pfSense opens fully, showing you the console menu with your configured network interfaces. Open your web browser and type https followed by :/, and then your pfSense LAN IP address in the address bar. Press Enter. Your browser will probably show a security warning about the certificate, because pfSense uses a self-signed certificate. This is completely normal. Proceed to the site anyway. The pfSense login page opens. Enter the default username as admin. Enter the default password as pfSense. Click Sign In. The initial configuration wizard opens to help you set up basic settings. Click Next to begin. The Netgate support page appears with information about support options. Click Next again to continue. The general information page opens where you can customize the hostname and domain for your firewall. I am changing the domain to cdm.local to keep everything consistent with our Cyber Defense Mastery Lab environment. Enter the primary DNS server, which is Google's public DNS. You can see the address on screen. Enter the secondary DNS server as Google's alternate DNS. Click Next to proceed. The time server configuration appears. Set the time server information according to your time zone from the drop-down menu. Then click Next. The Configure WAN interface page opens. Scroll down and press Next. The LAN interface configuration page appears next. Keep the LAN interface information as it is. Click Next. Now you need to set a new admin password for security. Enter your new admin password in the password field, then confirm it in the confirmation field. Click Next after entering your password. The Reload configuration page opens. Click the Reload button to apply all your configuration changes to the system. Wait for a moment while pfSense processes and applies all the settings you configured. After the reload completes, the wizard completion page appears. Click Finish to exit the setup wizard. You might see a license agreement notification appear. Accept the license agreement to proceed. The pfSense dashboard opens for the first time. This is your Firewall command center. Scroll down, and you will see both interfaces displayed with their current status and IP addresses. Below that, you can see CPU usage, memory usage, and other system statistics showing your firewall is operational. Now we start building the defensive rules that will protect your network. The first thing we want to do is create an alias for known malicious IP addresses. Aliases in pfSense are essentially named groups that let you reference multiple IP addresses with a single label. This makes rule management much cleaner and more maintainable. Click Firewall in the top menu, then click Aliases. Click the Add button to create a new alias. Enter the name as malicious IPs without any spaces. In the description field, write known malicious addresses so you remember what this is for later. The type dropdown should already be set to hosts, which is what we need. Now in the host section, you can enter known malicious IP addresses or ranges. Click Save to create the alias, then click Apply Changes to activate it. Now we create the actual blocking rule using this alias. Click Firewall again, then click Rules. We want to block threats at the WAN interface before they enter our network. The WAN tab should already be selected. Click the Add button with the up arrow to create a new rule at the top of the list. Click the Action dropdown and select Block. This will drop packets instead of allowing them through. The interface is already set to WAN, which is correct. Keep it as is. Click the Protocol dropdown and select any. This blocks all protocols from these IPs, not just specific ones like TCP or UDP. Scroll down and you will see the source configuration. Click the source dropdown and change it from any to address or alias. Click in the source address field and start typing the alias name we just created, and it will appear in the autocomplete. Select it. The destination is already set to any by default, which is what we want. We are blocking these source IPs regardless of where they try to connect. Check the Log Packets checkbox so every blocked packet gets logged and you can verify the rule is working. In the description field, write block known malicious IPs to document what this rule does. Click the Save button at the bottom, then click Apply Changes to activate the rule. Your first firewall rule is now active. Any traffic from IP addresses in your malicious IP's alias will be dropped at the WAN interface before it can reach your internal network. Blocking individual IPs is effective, but sometimes entire geographic regions are sources of attacks. pfSense has a powerful package called pfBlockerNG that enables geographic blocking using the MaxMind GeoLite database. Click System in the top menu, then click Package Manager. Click the Available Packages tab. In the search box, type pfBlockerNG Devil. This is the development version with the latest features and updates. Click the Install button next to it. Click the Confirm button to begin installation. Wait while the package installs. This takes a minute as it downloads and configures the components. After installation completes, click Firewall in the top menu. You will now see a new option called pfBlockerNG listed. Click it. The setup wizard opens automatically. Click Next to begin the initial configuration. Click Next button again to continue through the setup screens. The inbound and outbound interfaces configuration page appears. The default settings are fine for our setup. Click Next to proceed. The DNSBL configuration section appears. Ignore this configuration for now and scroll down. Click Next to continue. The configuration completes. Click Finish to exit the wizard. pfBlockerNG opens. Click the IP tab at the top of the page. Scroll down until you reach the MaxMind GeoIP configuration section. To use geo-blocking, we require an account ID and MaxMind license key from MaxMind's free service. Click the link to register for a free MaxMind account. The MaxMind GeoLite sign-up page opens. Create a free account here by filling in your information and submitting the registration form. After creating your account, you will receive an email from MaxMind. Open the email and click the password creation link inside. Create a strong password and click the Reset Password button. The sign-in page opens. Enter your account email as the username and click Next. Enter your password in the password field and click Sign In. MaxMind sends a one-time password to your email for verification. Open the email, copy the OTP code, and paste it into the verification field. Click Verify. After verification, you are logged into the MaxMind dashboard. On the left sidebar, click Manage License Keys. Scroll down on the License Keys page and click the Generate New License Key button. Enter a description like TechSky Lab or something meaningful, then click Confirm. MaxMind generates the license key and displays both your account ID and the license key on screen. Copy the account ID first. Go back to your pfSense browser tab. Paste the account ID into the MaxMind account ID field. Go back to the MaxMind tab and copy the license key. Return to pfSense and paste it into the MaxMind license key field. Scroll down and click the Save IP Settings button to save your MaxMind credentials. Click the Update tab at the top. Select Cron and click Run. pfSense now downloads the GeoLite 2 MaxMind countries data. Wait while the update completes. After the update finishes, click the IP tab again, then click the IPv4 tab. Click the Add button to create a new geo-blocking rule. Enter the name as Block Countries. In the description field, write high-risk regions to document what this rule does. Scroll down to the IPv4 source definition section. Click the Format drop-down and change it from Auto to GeoIP. Click the State drop-down and change it from Off to On to activate the rule. Now you can select countries to block. Here I am, adding some countries that are common sources of attack traffic. In production environments, you would base this selection on your threat intelligence and compliance requirements. Scroll down to the Settings section. Click the Action drop-down and change it from Disabled to Deny Both to activate blocking. Click the Update Frequency drop-down and change it from Never to Weekly. This keeps your geographic IP database current, as IP ranges change over time. Scroll down and click Save IPv4 Settings to activate your geo-blocking rule. You can now see both your manual malicious IPs rule and the geo-blocking rules that pfBlockerNG automatically created. Traffic from blocked countries is now dropped at the firewall before it reaches your network. Our WHEN rules protect against external threats, but we also need to configure LAN rules to properly control internal traffic. Let's create an explicit rule for DNS traffic to demonstrate proper rule structure. Click the LAN tab in the Firewall Rules section. Click the Add Top button to create a new rule at the beginning of the list. The action is already set to pass by default, which is what we want since we are allowing this traffic. Click the Protocol drop-down and select TCP/UDP. DNS uses both protocols for queries. Click the Source drop-down and select LAN subnets. This covers all addresses in your internal network range. Scroll down to Destination Port Range. Click the drop-down and select DNS, which is port 53. Scroll down further and check the Log Packets checkbox so you can track DNS queries in your logs. In the description field, write explicit DNS to document that this rule specifically allows DNS traffic from the LAN. Click the Save button, then click Apply Changes to activate the rule. Your LAN now has a clear, documented rule structure. Necessary services like DNS are explicitly allowed with logging enabled for visibility. Now we install the component that transforms pfSense from a firewall into a full intrusion prevention system. In our previous lab, Suricata ran on Ubuntu server in detection mode. Now we are installing it on pfSense in prevention mode, where it can actively block threats. Click System in the top menu, then click Package Manager again. Click the Available Packages tab. In the search box, Type Suricata to find the package. The Suricata package appears in the results. Click the Install button. Click Confirm to begin the installation. The package downloads and installs. This takes a few minutes because Suricata is a comprehensive intrusion prevention system with extensive capabilities. After installation completes, click Services in the top menu. You will now see Suricata listed in the menu. Click it. The Suricata Interfaces page opens. Click the Add button to add a new interface where Suricata will monitor traffic. Change the interface from WAN to LAN. We want to inspect all traffic going to and from our internal network. Scroll down to the Alerts and Block Settings section. Check the Block Offenders checkbox. This is the critical setting that enables IPS mode. Click the IPS mode drop-down and select Inline mode from the options. A pop-up appears with important information about inline mode and how it works. Read the information, then click Close to dismiss the pop-up. Scroll down and click the Save button to apply the configuration. You might see some warnings appear. These warnings are normal for initial configuration. You can resolve them later or ignore them for now during this lab setup. Click the LAN Categories tab to view the available rule categories. Scroll down and you will see it shows various rule categories that Suricata can use. However, some important categories are missing because we have not downloaded them yet. Let's add them. Click the Global Settings tab at the top. Check the box to install the ET Open Emerging Threats rules. This enables the free community-maintained rule set. Scroll down and also check the abuse.chssl blacklist rules to add certificate-based threat detection. Scroll down and click the Save button to save these settings. Click the Update tab at the top. Now press the Update button. Suricata now downloads the additional rule categories you enabled. Click the Interfaces tab to return to the interface list. Click the pencil icon next to the LAN interface to edit its configuration. Click the LAN Categories tab to see all the available rules now. Now you can see all the downloaded rule categories. Check the rule categories you want to enable. I am checking abuse.ch rules, emerging attack response, emerging exploit, emerging malware, and emerging scan to cover the most common attack vectors. Scroll down and click the Save button to apply the selected categories. Now we start Suricata monitoring. Suricata is now running in IPS mode on your LAN interface, actively inspecting every packet and blocking threats in real time. Right now, your virtual machines still have NAT adapters enabled, which means they bypass pfSense completely and connect directly to the internet. We need to reconfigure them to route all traffic through pfSense so they benefit from firewall protection and IPS inspection. Click on any machine and open its network settings. You will see there are two adapters we set up in the previous lab. Let's disable adapter 1, which is the NAT adapter. Click OK to save the changes. Do this same process for the remaining 3 virtual machines. Configure each machine so they use internet only through pfSense. Start Ubuntu server. I am opening it through SSH on my host computer to work remotely. Try pinging Google's DNS right now. You will see it shows network is unreachable because there is no route to the internet anymore. Run this command to check the network interfaces. You can see ENP0S8 is shown with your host-only IP, but the NAT interface is not shown. In the previous lab it was shown as ENP0S3, but now it is gone since we disabled it. To configure the server to use pfSense as the gateway, open the netplan configuration file. Run sudo nano/etc/netplan/00-installer-config.yaml. The file opens, and you can see the old configuration. We don't need the ENP0S3 section anymore, so remove it completely. Now edit the file in the correct format with correct spacing. Under the ENP0S8 interface, you will see DHCP4 is set to true. Change it to no. Below that, write addresses : On the next line inside square brackets, write your machine's IP address in CIDR notation. Below that, write routes : Under it, write --default. Below that, write via : and here write your pfSense IP address. Below that, write name servers : under that, write addresses : inside square brackets, write Google's primary and secondary DNS server IPs. Make sure your spacing is correct, because NetPlan is strict about indentation. Save the file. Type sudo netplan apply and press enter. Ignore the warning that appears. Now run ping again. It is reachable now. Your Ubuntu server is routing through pfSense successfully. Open Ubuntu Desktop and do this same process. But the file name is different. It is 01-network-manager-all.yaml instead. Configure it exactly the same way with the same structure. Make sure you follow the correct spacing structure when editing the file. Now open your Windows 10 virtual machine. In the search bar, search for Settings and open it. Click Network and Internet. You will see Internet is not connected. Click Ethernet to Properties. Click the Edit button to change the IP configuration. Select Manual from the drop-down. Click the IPv4 toggle button to turn it on. Enter your Windows 10 IP address. Enter the subnet prefix length as 24. Enter the gateway as your pfSense IP address. Enter the preferred DNS as Google's primary, and the alternative DNS as Google's secondary. Click the Save button to apply the network configuration. Windows will ask when PC discoverable by other PCs on the network. Click No for security. Internet is now enabled without using any second adapter as NAT. All traffic routes through pfSense Firewall, giving you complete protection. Let's test our intrusion prevention system now. Go back to your pfSense Suricata page in the browser. Click the Alerts tab for the LAN interface. You might already see some alerts from normal network traffic. Click the Clear button to start with a clean slate. Now open Ubuntu Desktop. We are going to trigger a test signature to confirm Suricata is inspecting traffic. In the terminal, type curl test mynids.org/uid/index.html and press enter. You will see some text displayed that says, UID equals 0 root access. This is a harmless test website designed to trigger IDS and IPS rules for testing purposes. Go back to pfSense and refresh the alerts page. You can see a new alert has appeared. It shows the Suricata rule that was triggered, classified as potential bad traffic. The alert displays your Ubuntu desktop as the source connecting to the test site. Notice that the action shows alert, not block. Suricata detected the traffic and created an alert, but it did not block it yet. We need to change this rule to drop mode. Click the alert action icon. Change the action type to drop. Click Save to apply the change. Suricata will now block this traffic pattern. Wait about 15 seconds for the change to take effect in the system. After 15 seconds, go back to your Ubuntu desktop terminal. Try to run the same command again. This time you will see the command hangs or times out. No text is returned. The connection was blocked at the firewall before it could complete. Go back to pfSense. You can see the new alert now shows the action as drop instead of alert. The malicious access was stopped at the firewall. Your Ubuntu desktop never received the response because Suricata blocked it in real time. This is intrusion prevention working exactly as designed. Real-time blocking based on threat signatures protecting your network before attacks can reach your endpoints. Save your work by taking snapshots of all your machines in VirtualBox. If you made it this far, you are not just learning concepts from a textbook or watching someone else do the work. You are building production-grade security infrastructure with your own hands. The firewall you configured today could genuinely protect a small business network. Tell me in the comments what surprised you most about this lab. Your feedback helps me understand what resonates with you and directly shapes the content I create for future videos. Until then, this is TechSky. Stay sharp, stay secure,